Greetings, ladies and gentlemen. Welcome to my YouTube channel. Today we'll be posting our very first video talking on parallel programming and distributed system. And under parallel programming and distributed system, we'll be talking on uh, why parallel programming. Our objectives will be having what is parallel programming, why we build parallel systems, advantages, disadvantages of parallel programming, how to how do we write parallel programs, difference between shared and distributed memory, forms of parallelisms and problem faced by parallel system. On our first point, we'll be having what is parallel programming. Parallel programming is a model that aims to create programs that are compatible between various environments ready to execute code instructions simultaneously. That's an environment presently formed for execution of code to facilitate and ease uh, some task. Or in other words, it's a process of using a set of resources to solve a problem in less time by dividing the work, that is fragmenting the work into smaller tasks. And you can follow on that and see another base definition of programming, parallel programming, which can help you understand more better. But the main aim of parallel programming was to break down larger informations into smaller pieces to save time. We also move to why we build parallel system. This is obvious. You can imagine yourself dealing with a very large information and using a one task, attributing them to a one processor, which will take longer time. It may or may not even be accomplished. So reason why we could call in the parallel system will help us to fragment and to break it down. Like we said here, one of the main purposes of building parallel system is to perform or improve on computation faster than can be done with a single processor by using a number of processors. Currently, that's using so many processors to break down or to fragment the work. And below, you can find some different other reasons why we build parallel system, which is parallel computing deals with larger problems. That's true. Large information, large resources. In the real world, there are multiple things that run at certain places, but at numerous certain time, but at numerous places simultaneously, which is difficult to manage. And here comes the parallel computing, can be known also as parallel computing or parallel system, to help manipulate this huge data. We took example of like a meteor that you can't really access this on one processor. You need to separate, to share these tasks to different processors for a quick and efficient execution and reply. On talking of parallel system, we can't talk of parallel system without talking of parallelism. Talking about parallel, we come to notice that the main answer is parallelism, and we can define it as a technique to make program faster by performing several computation at the same time. That's performing several tasks at the same time, to sharing it to different processors. As it can be known as multiple processing unit. We move directly to advantages and disadvantages of parallel system of parallel programming. The main reasons of parallel programming is to minimize time, to increase efficiency, and the modeling too. So here, one of the advantages we can talk about is the main reason for parallel programming is to execute code efficiently. Since parallel programming saves time, allowing the execution of application in a shorter world clock time. As consequence of executing code efficiently, parallel programming often scales with the problem size and thus can solve larger problems in a general and the real world. Parallel programming is a means of providing concurrency, particularly performing simultaneously multiple action at the same time. That's like we said earlier, using a parallelism and the breaking down of larger, of huge information. That is an advantage of using the parallel system. Without wasting of time, we can't be listing them all, but you can go detailing into the advantages. And here we have an example. If you can see here, we said an example: the speed of a sequential computer depends on how fast data moves through its hardware. That's a clear explanation of the parallelism. And also for the speed, the transmission through a physical medium is restricted by the respective bandwidth of such a medium. For example, the speed of light or the transmission limit of copper wire. That's the speed in which it can communicate between themselves within a hardware. And talking of disadvantages, we also have disadvantages which are highlighted just one, but we will see into detail in our next video. It requires a managed algorithm which could be handled in parallel mechanism. The multiple core architecture consume high power consumption. The parallel computing system needs low coupling and high cohesion, which is difficult to create. Like we said, using the parallel system and the parallelism form, we are obliged to use so many processors which need to be constantly supplied, so it consume high power consumption, which is difficult to create and to maintain. There are also to finance them. So these are the advantages and the disadvantages of using the parallel programming, and we find out that the advantages are more secured and more explicit than its disadvantages. We move to how to write parallel programming. Some people ask themselves how to write parallel programming and all the like. Parallel programming is just a kind of code that is an instruction you are requesting. You are writing an instruction to fragment or to appease the work you have within your range. Like we said, parallel program focuses on programming techniques for the largest class of parallel machines, generally purpose asynchronous machine. It outlines the basic parallel algorithm classes and the three basic programming paradigms. It takes up the implementation techniques for these paradigms and presents a case study explaining code and discussing its measured performance. So in our next video, I will kind of show you guys a clear code and a diagram showing you guys how to write a parallel programming. So here we're just like trying to focus on the main points, the main reasons of writing the parallel programs. So we also say, you can also find out, we say it is said to be so because parallel programming requires both programming language and a cardinal language. The author used C to combine it simply and efficiently implemented on a wide range of machines because it is more compatible on almost all kinds of machines. So this is why how to write parallel programming. We take in consideration the three main paradigms and the efficiency of implementing it on several environment, that's execution environment. We move to difference between shared and distributed memory. Here, just from the name shared memory, we come to find out that shared memory can be defined as a machine having so many hearts or processors that access on the same memory or kind of resources. Reason we call it a shared memory system. Thus we enlightened some 4 points which says the cores can share access to computers memory. That's all of them have access to the same and on one memory. Each core can read and write each memory location, and they also have to intercommunicate using the p-thread or the open MP, which stands for message passing within the system and not out of the system. And we can also notice that in the shared memory, the time of execution is elevated because so many of them try to move into the memory to read, to write, or to access some resources. Reason we say a shared memory. In conclusion, a shared memory is not really the best, but can perform some tasks more easier if they were reduced or simultaneously. I will move to a distributed memory system, which we have so many machines which look as one, so they are kind of virtual. For some people, they may think we have just one machine, whereas we have a set of computers, and here each machine can access its own memory without interfering with the other. Like we said, each core has its own private memory where it can access and store its resources. The core must communicate explicitly by sending messages across a network, and that's true. And when we talk about distributed memory, we also talk about networking, because it must be interconnected to share some resources. And the medium of them sharing that resources is known as what we call the MPI, which is known as message passing interface. And also notice the time of execution is reduced, because due to the sharing of different tasks to different processors bring a quicker response and brings out efficiency and accuracy. So we move to what we know we call the forms of parallelism. Obviously, we must have what we call forms of parallelism. We have the concurrent computing, the parallel computing, and distributed computing, excuse me. And under what we call the current concurrent computing, this is where so many tasks are striving to have access for a progress in their execution at any instant. They are trying to access all the time. Like we said, a program is one in which multiple tasks can be in progress at any time. The CPU scheduler dispatches several workers, and these workers dispute to use the CPU. That they may be dispatched according to their size, according to their priority, or according to the information they required in the CPU. So this is what we can talk on concurrent computing. It means concurrent, like the name says, progressing at any instant. We also talk of parallel computing. We move alongside like a shared memory. The both of them are being that they execute their programs simultaneously. So we can say a program is one in which multiple tasks cooperate closely to solve a problem. It's a cooperation, like they intershare their resources for them to move, as to have access to a next level. For instance, you can take a program that needs to calculate the time, and the first processor needs to give you the resources needed by the second processor to give you the accurate time of execution, or something you wrote in your code. So this is exactly what we're talking about. And programs that create workers to run specific tasks simultaneously, like we said, it's a multi-core environment. You attribute different tasks to different processors to execute them on different states. So this is all we're talking about in parallel computing. And we'll talk also on distributed computing. A program may need to cooperate with another to solve a problem. Possibility of sharing the processing by exchanging data through message between machine, that's nodes or computing, which are physically separated. Like we said, distributed memory, they are separated but they look as one, because they intercommunicate and their resources are available at any instant simultaneously. So from these three forms of parallelism, we can see that the fault of tolerance is low, the scalability is low, and cloud computing, they really work, they really do it in a good way. It is efficient and modeling. And here we come to the last part of our chapter 1, which is why parallel programming, which are the problems faced by parallel programming. We have what we call the deadlock, starvation, and race condition. What is deadlock? It's a situation in which two or more workers keep indefinitely waiting for the freeing of the resource, which is blocked by a worker of the same group for some reasons. For instance, imagine in a shared memory where the one processor is striving to have resources from the memory, whereas another processor is within and trying to being executed, or to is waiting for its reply. So the period within the response of the second processor is known as a deadlock. He is striving, he is starving to have to access resources on the same machine. Whatever we call a starvation, like he says, he is starving to have resources too. Imagine a group of process A which runs heavy tasks and has data processor priority. Here we'll be talking of the priority now on each task. Imagine you are trying to compile a form of document and a calculation of addition. You find out if the file is more prioritized than the calculation, because the file is needed to solve in the calculation process. So the processor A will be in the CPU, why the second processor, which is B, will be starving to have access to those resources, and to also have access to and also to be executed. We have what we call the raised conditions, when the result of a progress depends on a sequence of facts, and this sequence is broken due to the lack of synchronizing mechanism. Here we're just talking of like, it's a dependence. You depend on the result of another process due to the sequential fact. You don't know when it starts nor when it ends, so it is really a problem faced by parallel systems. So we thank you for watching our video. I will please recommend you to share, like, and to subscribe. Meet you later.